In this video, we're going to look at congruent statements, similar figures, scale factor, and also looking at congruent triangles. Here we're shown two figures, and that they're both congruent and they're quadrilateral. So they want us to write all the congruent statements. First, we're going to start off by saying that the one figure is congruent to the other. So we can say that quadrilateral MATH is congruent. That symbol means congruent to quadrilateral Coke. And we have to make sure that we match up the angles here. For example, M has one arc, and so does C. So those have to both go first, and so on. A has two arcs, so does O. So those have to be in that order because they correspond with one another. This symbol here does mean congruent. We can also write congruent statements for all the angles. So we've got four angles. We've got angle M, angle A, angle T, and angle H in the one quadrilateral, and they're going to be congruent to another angle in the other quadrilateral. M has one arc, so does C, so angle M and angle C are congruent. A has two arcs, so does O. T has three arcs, so does K. H has four arcs, so does E. So those are all the congruent angles. We can also write congruent statements for the sides. And if you look in the drawing, like MH has MH has one slash. So that segment is congruent to the other figure that has one slash. That's going to be CE. Again, the order is important. If M's listed first, the C has to be listed first because they'll both have one arc. And we've got MA, which is congruent to CO, line segment CO. And we've got AT, which is congruent to line segment OK. And we've got TH, which is congruent to KE. There's all the congruent statements. One to say the one figure is congruent to the other, all of them for the angles, all of them for the sides. Here we're given that the two triangles are congruent, and this symbol that's in here, again, that symbol means congruent. Alright, so here B is listed first. That angle is congruent to angle Q, so I'm going to put one arc to indicate that those angles are congruent to one another. C is the second one, or the middle one, so is R. So C and R go with each other. I'm going to put two arcs to indicate that those two are congruent to one another. And D and S are both the last one, or the third one listed there, so those are going to be congruent to each other. I'm going to indicate that with three arcs. Okay, now the angles are labeled, now we need to label the sides. Looking at the order here, BC is the first two, so it's congruent to QR because the order does matter. So BC, I'm going to put a slash through that side there, and that goes with QR. Okay. If we look at CD, the last two letters, RS, so CD and RS go together. I'm going to put two slashes for that, which leaves the last side, and there we go. So we put a slash to indicate which sides are congruent, and we put the arcs in to indicate which angles are congruent. Right, here we're given that triangle ABC is similar to triangle QRS, and this symbol in here means similar in mathematics. We can match up corresponding sides here. So I'm going to say, okay, this side here in green goes with this side. So I'm going to say that the 12.5 goes with X. And then I'm going to match up another pair of corresponding sides. We've got this one here can match up with this one, so we can say 7.5 is to 3. Now we've got a proportion, and we can just cross multiply and solve that. So we can do 7.5 times x, which is 7.5x. And then we have 12.5 times 3. And on the left we have 7.5x. On the right, when we multiply 12.5 by 3, we get 37.5. Divide both sides by 7.5 to get x by itself. And we find that x is 5. So the length of this QS is going to be 5. Alright, we're given that these triangles are similar, triangle ABC to triangle JKL. It asks us to find the scale factor, so I'm just going to match up corresponding sides. We've got this here, which corresponds with that, so we could say 4 is to 2. Also look at another pair of corresponding sides. We've got 10 is to 5. And if we match up another pair of corresponding sides, we've got this one and that one. And if these are similar, those should all be the same scale factor. If we simplify all of those, they all simplify to 2 over 1. So the scale factor here is going to be 2. In similar figures, their corresponding angles are congruent. So you'll see that it says, what is the measure of angle K? K has 3 arcs. If we look in the other triangle, B has 3 arcs. So that's congruent to angle B, which is 30 degrees. If you look at angle L, it has 1 arc. So does angle C. So it's going to be equal to angle C, which is 100. And J has got 2 arcs, so does A. A is 50 degrees. Alright, so we have 3 ways, or here's 3 ways you can prove triangles congruent. So one way is the side-side-side postulate, which is SSS, and that just says that 2 triangles are congruent if the sides of one of the triangles is congruent to all the other ones. So if you can see here in the drawing, we've got, that side is congruent to that side, and we've got this side being congruent to this side, and we also have this side congruent to that side. So all 3 sides of this triangle are congruent to 3 sides in that triangle, and that's side-side-side postulate there. Okay, side-angle-side postulate says if we've got 2 triangles congruent to one another, that means that they have a pair of sides that are congruent, and the included angle in between them is also congruent. So if you look here, we've got those sides in red there are congruent, so that's 1 pair of sides. We've got this pair of sides, so that's 2 pairs of sides, and then we got to look at the angle in between them, and this angle here with 1 arc is shown with this angle here, so this one is side angle side. The last way here on this particular slide here to show that 2 triangles are congruent is the angle side angular postulate, so the ASA. That just says if we have a pair of angles in one triangle congruent to another pair of triangles in the other with the side also included between them, that they are going to be congruent. So if you look, we've got 2 arcs there, so that's 1 pair of angles. The other pair of angles is the 1 arc. And then for it to be angle side angle, we need the side that is in between those 2 angles, and that would be there. So this one is angle side angle.